Hello YouTubers. This video is a small demo on how to normalize and scale analog input value. Please do not forget to like the video and subscribe to the channel. Let's get started. As you know, analog values in Siemens world are converted into digital representation between 0 and 27,648. So, for example, if you have an analog value 0 to 10 volts from some sensor, by the help of the analog to digital converter it will be converted into linear value, where 0 volts are represented as 0, and 10 volts represented as 27,648. Samples between 0 volts and 10 volts will be within 0 and 27,648. It applies to other measurements as well. That kind of the conversion provides good precision, but value 27,648 or 11,820 or 2,864 isn't very useful. To display such a value in the HMI as meaningful value, it needs to be normalized and scaled. Here comes instructions norm X and scale X. These instructions can be found in the folder named Conversion Operations under the Basic Instructions. Instruction norm X, called normalize, maps input value to linear scale within value range between 0 and 1 of the data type of floating point. Value 0 of analog to digital converter will be decimal number 0, and value 27,648 of analog to digital converter will be decimal number 1. Instruction norm X has 3 integer type input parameters, min, value, and max, and 1 floating point output out. Min and max parameters define the limits of value range which applies to scale. In this example it is 0 to 27,648. Parameter value is the value that needs to be normalized. Out is the result of the instruction, calculated by the following formula. Drag and drop the norm X instruction into the network. Assign min and max values as tags or constants. Assign your analog input to instructions input value. Save the result value into some tag as floating point. Let's test it. By the help of the slider I am going to simulate analog input. As you can see, normalized value changes according to the input value within limit of 0 and 1. Next step is to scale our norm X result. At this point you can use a simple math instruction, called multiply. Let's say, if you want to read value 0 to 10, then you need to multiply result by 10. Let's test it in action. Now the output value changes within 0 to 10. Same applies if you want to read values within 0 to 5 volts, or 0 to 20 milliamps. But what about 4 to 20 milliamps? In this scenario your full scale is 16, while minimum value is 4 and maximum is 20. Multiplication cannot be used as it is done now. At this point you have couple of possibilities. First one would be multiply the result by 16, and add bias, which is 4 in this scenario. Let's test it. As you can see, the lower value is 4 now. Let's move the slider to the top. Result is 20. So, result is within 4 and 20 now. Another option is to use instruction scale X. I will adjust my program a little bit so that math functions will not take any effect on the result. Add the scale X instruction to your program. By the help of this instruction, I am going to scale normalized value within limits of 4 and 20. Upload the program to the CPU, and let's see how it works. As you can see, result is within 4 and 20. You can change those limits to the ones that are suitable to your needs, so you will get a different scale. That is what I wanted to show you today. If this video was useful, please do not forget to like it and subscribe to the channel. Thank you for watching and happy coding.